Hello, this is IoT for coming up with different solutions for an IoT setup or IIoT setup. Um, so first scenario is basically create a system that detects the doors activity. So I figured it doesn't necessarily need to know how long the doors are open because it's not what it's asking for. So to not over-engineer the system, this solution I came up with. So basically, read switch turns on or off the ESP01, and then it's powered by an 18650 battery because if it's like, let's say the little coin cells, I think they're good for about 20 open doors. And so basically, the EPS01 stays dormant till that read switch triggers, and then it turns on. And then it connects to the router. This is about 4 seconds, which seems adequate for this situation. And then it goes to MQTT, over MQTT, past the edge, and then to the cloud layer. So with the cloud, so like ThinkSpeak or something, this collect the data, potentially send out a message if the doors open or close, depending on if it's the back or the front. So if we go over to scenario 2, so in scenario 2, as you can see, it's a shipping or a company that's shipping to 7 different nodes, and they want to place a small device inside their crate. Basically, tracking for damages, tipping, being dropped, and then identifying the location when that happens. So with that, my solution, so basically triple axis accelerometer. This will track tipping, so if it gets over a threshold, it'll trigger, or if it gets over a certain G, then it'll trigger. And then a humidity sensor to track moisture. Let's say it's sensitive and it doesn't need too much moisture, that would be also important. Which goes to the microcontroller, and then it's powered by a battery pack. And so if one of these reaches a threshold, then it'll trigger, and then it'll send over Wi-Fi, the 802.15.4. This is a low power Wi-Fi, but but adequate range. Unlike low ra wah is that's long range, so it's not necessarily what we're looking for either. So this is a good middle ground for what we need. And then from there goes to the mini PC. So the mini PC is powered by the truck battery. So the idea is basically that most things get shipped in the Connex, probably 99.9% of items, not for sure, or like in a metal box, not necessarily Connex, but just a metal box. So let's say like a train, like a shipping container of some sort. So the GPS won't really work that well inside of there, so I thought this would be a good solution to be able to get the GPS outside of it, but also connect it to the pallet itself. So mini PC gets that information, then when it receives that information, it'll pull the GPS data, and from here it can kind of collect data and wait till it gets to a node spot, or if you want to, you can transmit the data as it receives it, because this is, important, valuable information of like, hey, maybe this device got destroyed right now, and then you can kind of act more accordingly in real time versus at the node stations, which also gets rid of the situation of how to transmit the data once we get to the station, because then with this, it can just send it over 4G network when it gets into signal range. And then from there, 4G with MQTT, and then it can go to ThinkSpeak, where it can then transmit data to, let's see, it can process the data, it can, you can also translate it into like email form or something to basically alert you that it also got damaged and needs to be acted on accordingly. If we go to scenario 3, so this is an agricultural scenario. It's 1.22 miles distance, so it's a long range, and basically tracks the water pump, and monitors operations of the water pump. So for that, just a little picture to kind of show. And then you got the motor, and then I chose a flow sensor and a split core Hall current sensor. So basically this just pops over the wire showing that there's current. And so this does a couple things. Basically shows that the motor's on and the water's flowing. Potentially if the water's flowing and the Hall sensor is not picking up current, that would mean that there's a leak. Or let's say it starts to notice that the current is drawing higher, and let's say the flow sensor isn't, the flow rate's not going as much, maybe, worn out bearing or something. That would be something to adjust too. So that goes to a microcontroller, which can be powered from the power source that the motor's getting the power source from, or even maybe it's easier to do a hydro kind of power system, or what's the word I'm looking for? Solar power to power up the microcontroller. The microcontroller goes over MQTT, and then over low raw wah. And so with the low raw wah, it's a low power consumption long range. So, and I think it can go from 10 to 25 miles depending on or kilometers depending on the system. So 0.22 miles is probably about 2.5 kilometers. This is very adequate for this situation. And then let's say a Raspberry Pi receives the information, and then from there it reaches the edge. So from local area network to the larger area network, it can transmit over MQTT to ThinkSpeak or another cloud-based area, which it can process data. And then let's say it starts to notice something's going a little awry, it can send information or send out a trigger email or information to a website or something. Probably would also have I didn't draw it in, but would have a display at the Raspberry Pi. So if you have like 5, 10, 15 of these systems, you can just have a quick glance at that portion and just look at the information too that way. So if we go over to number 4, so in this situation, it's asking for a few different things: RPM, how long somebody's used the trainer for, somebody's requesting into a lab, and 2 3D printers. So with that, if we go over to the solution, so it might be kind of a little hard to see just because it's a little small, but we got the motors, which are want to record the RPM. So VFDs control the RPM, and those are actually the models that we have in the lab are able to transmit out the RPM data, so you can do that over RS-485. And then this will go to, let's say, the broker of 2040, which is powered by a wall power. And then that can transmit data over Wi-Fi to MQTT to the router, and then that passes the edge and goes into the wider area network, which is still MQTT to ThinkSpeak, and basically can record that data. It can kind of filter it out because it wants it over time, so maybe it's, let's say every 5 seconds when it's on, it sends out, like, this is the RPM, and depending on how accurate you want it, or if you just want a rough RPM over time. So the next part is the AC trainers. It wants to know if it's on. So the first solution was to use the Hall sensors over the wire to sense if it's drawing current, but that doesn't necessarily mean it's on, because the student can be out there and not necessarily be running any power through it at the particular time. So I figured relays are probably better. Basically when the trainer gets switched on, then it can close the circuit on the M4 Express or ESP32, which then transmits over Wi-Fi to the 2040 and then completes the system. For the third part, the doorbell access, push button, so it could just be like a standard doorbell where it's just closing the circuit, on, off, goes to M4 Express or ESP01, gets the wall power, and then transmits data to the router. So this could potentially be a different router since it is upstairs. It could possibly be the same router. Don't know where the router signals quite meet, so I just assumed it would be a different router. And then it would also go to ThinkSpeak, and then because you'd want this information so you can actually let the student in. This would go to like an app. You could make an app like an MIT app, or you could email, or you could do a text message or something, depending on what kind of exactly you're looking for. And for the fourth solution was the 3D printer. So it wants to know what it's running. So there's a couple different options. This is kind of like the gold star solution. Another would just be to put like either, some sort of current sensor, the Hall sensor, or like something that detects motion on the 3D printer, and it's able to send information out that way. But so this one gives you a lot more kind of feedback of what's going on with the 3D printer. I think you can even do video of the 3D printer with this solution. So it transmits data over USB to the Raspberry Pi, and then from there it goes Wi-Fi, MQTT, the router, and then so Octopi is kind of the brains of this solution. So you could do Octopi and then kind of forward to ThinkSpeak, to then go to, to be able to process the data. So Octopi allows for more interaction with the 3D printer, and will be able to give you more data if that's what you're looking for, or you could go with that other solution where it's just like, something detecting the motion. And so for that, we go to the final solution, which is DIY. So with that, I kind of stuck with a sport that I'm familiar with, and the idea with this was to go, so like with downhill mountain bike racing, milliseconds count, everything counts. So I thought it would be cool to create a system where it has 3-axis accelerometers. So there's 3 of them, one on the wheel because it's a full suspension bike, one on the front wheel, and then one on the frame itself. So I thought that if you process the data right, you'd be able to tell like if you have a front impact hard or back impact hard, or just how your bike is balanced out through particular areas and sections. This would also transmit GPS data. So, and then also I thought maybe an encoder on the handlebar, so handlebar position in a particular area might be important too. And so the idea was this would allow you to basically be able to compare your data between other runs, like why am I slower in this now than let's say earlier in the day, or how are you comparing to let's say your other team riders, and like where everybody can improve based upon that data, because in mountain bike racing you get a couple days to practice the trail before you do your race run. So with this said, you basically can have enough time to actually process the data, or you have enough like different runs to basically improve what you're doing. So with that, it would all go to a Raspberry Pi with a power source, hopefully keeping the power source fairly lightweight, and then over the whole race run, which is 3 to 5 minutes give or take, it records the data, and then from the bottom, once you're done with the run and it gets all the data recorded, then you could transfer it over Wi-Fi, which might not necessarily be the most ideal situation, so that's why I said or 4G, because a lot of times you are in the middle of the woods far out. And then from there, transfer it to ThinkSpeak, where it's able to process the data and kind of compare everything. This is a little more data intensive than the other situations, just because you do need more real-time data. Well, you need more data points and a lot more of them to see where you're getting held up in the race or in the bike trail. And so that is my 5 solutions for IIoT.